Hi, my name is Saud Aldosary. I'm PhD candidate working under the guidance of Dr. Aberzeskaya at Howard University. The title of our research is Non-Hyperbolic Critical Point of Two-Dimensional Discrete System. So we start with the introduction. Let 0, 0 be an isolated equilibrium point of the difference equations, which actually is Euler approximation of the ODE system. And PM and QM are a homogeneous polynomial of the mth order. Note that point 0, 0 is called non-hyperbolic equilibrium point if ODE of a difference equation if at least one of its eigenvalues equal 1 or -1. Also, on ODE system, we call point as non-hyperbolic point if at least one of its eigenvalues equal 0. Remember from Andronov, 0, 0 can be either monodromic or all orbits of the ODE system tending to the origin. Also, we can state that a small enough neighborhood of an isolated equilibrium point to classify to 3 sectors: parabolic sectors and hyperbolic sectors and elliptic sectors. Question: what is the behavior of the orbits and phase portrait of the difference equation in case when the isolated point 0, 0 is non-hyperbolic? Method. First, we present the system of difference equation that qualitatively approximate the behavior of the ODE system. And second, we use the blow-up method. And third, we glow the hyperbolic equilibriums and return back to give the final structure of the isolated point 0, 0. In our system 1 difference equations, if m equal 1, so the structure of the neighborhood of 0, 0 is already explained by Al-Ayadi. If the mean attention is given when m equal 2. We have a condition of non-degeneracy. So the point 0, 0 is an isolated fixed point if satisfy these two conditions, A1 and A2. Also, our system, a difference equation system, is non-degenerate if a neighborhood if it satisfy also these two conditions, B1 and B2. We have an auxiliary system of the origin system. A blow-up method is a transformation tool that allows us to desingularize non-hyperbolic equilibrium points to hyperbolic equilibrium points by using the change variables yn equal un xn and xn equal vn yn. This proposition show us to transformation from xy plane onto the xu plane by using the change variable yn equal xn un. Also, by using the other change variable xn equal vn yn, we can transfer from xy plane onto the vy plane. So after we use the change variables, we have a new systems. So from the previous new system, we need to find the new equilibrium points. So by these polynomials, we can find these new equilibrium. So we need to check the stability and the behavior of the new equilibrium point. So by these eigenvalues, we can check the behavior and the stability. And remember the classification of difference equation determined by trace and determinant. Corollary, the eigenvalues that we get from a new equilibrium points cannot be 1 or -1. Proposition 3, there exists h greater than 0 such that the fixed point 0 u star of non-degenerate system 7 is a saddle if the derivative of phi 1 with respect to u at u star product to pm at 1 u star less than 0, and node if their product greater than 0. Proposition 4, let u star less than u double star be a neighboring roots of the polynomial phi 1 at u. And let these 2 points be neighboring equilibrium points in plane x u, and h is bounded between h star and 0. Then we have first, if fixed point 0 and the other point 0 u star are saddles, then the hyperbolic sector corresponds to them in a plane x, y. Second, if fixed point 0 u star is a saddle and the other one is node, then repealing parabolic sector is placed in x, y. And third one, if the fixed point 0 u star and 0 u double star are sync node and source node, then the elliptical sector is placed in the plane xy. We have a term here. We have a possible type of the topological structure of the point 0, 0. The first type, two hyperbolic separated by two parabolic sectors, such that one of the sector is sink and the other sector is a source. The second type, two elliptic sectors separated by parabolic sectors, such that one of the parabolic sector is a sink and another is a source. And the third type, 6 hyperbolic sectors. And the fourth type, 2 hyperbolic sectors. Example, if we have two-dimensional difference equation and arbitrary coefficient chosen, then we have after blowing up, we have 3 equilibrium points. All of them are saddles. When we grow these points, we have 6 hyperbolic sectors. Also, if after blowing up, if we have 3 equilibrium point here, and when we glow them, we have 2 hyperbolic and 2 parabolic sectors. Conclusion: in this work, we develop a method of analysis of non-hyperbolic equilibrium for two-dimensional homogeneous system. We present the system of difference equation that qualitatively approximate the behavior of ODE system. We using the blow-up method to split a non-hyperbolic point into finite number of hyperbolic equilibrium points. Finally, we glow the hyperbolic equilibriums and return back to give the final structure of the neighborhood of 0, 0. I would like to thank Dr. Borozewski for her knowledge, motivation, patience, and and guidance with this research. Thank you.